Alrighty, so we're going to talk about angle pairs, and specifically we're talking about a certain type of angle pairs created by a certain type of lines. So here on the left, I have a picture that has A, B, and T lines, angle or line A, line B, and line T, and they create some intersections. The difference between what's happening on the left and what's happening on the right, they both have this transversal or this line that cuts through a set of lines. What is different is that on the right here, we have what's called parallel lines. And so these lines sometimes have an arrow on them, and it means that they are never going to cross each other. They are the same slope. They are essentially the same line moved over. We are going to pretend, even if your picture looks like the picture on the left in your packet, that we are working with parallel lines. Okay, that's what allows some properties to hold. So our first type of angle pair we have is adjacent angles, and adjacent angles share a side, meaning that they are something like, and I would use some sort of symbol to represent angle 1 and angle 2. Those are adjacent angles. Example is angle 1 and angle 2. So we have angle 1 and angle 2. Another example would be angle 5 and 6, or angles 1 and 3, anytime we share a side of that angle. Okay? The next type of angle we have is corresponding angles, and they are in the same relative spot, meaning they are in the upper left, or the lower right. So upper left, they're in the same like coordinate position that we have. The next type is alternate interior angles. So alternate interior angles are between the lines on opposite sides of the transversal. So that would be like 3 and 6, because they are on the inside of this angle pair, this space in between here. I would not write that. But that inside space and on opposite sides of the transversal. 4 and 5 is the other set of alternate interior angles. Similar to alternate interior angles is alternate exterior angles. They are outside the angle pair. On opposite sides of the transversal. Not the angle pair, sorry, the side pair, the sides, lines. On opposite sides of the transversal. So that would be like 1 and 8. They're on opposite sides of that transversal. They are on the outside of our line pair. Okay? They go across like a diagonal. And lastly, we have consecutive interior angles. Those are angles on the same side. Before I write that, they are on the inside or between the lines on the inside, same side, sorry, same side of transversal. So that would be like 3 and 5. They're on the same side of the transversal, they're on the inside, and 4 and 6. Okay. Now we look at adjacent angles and consecutive interior angles. Your packet might not be like grouped like this, so what I want you to do is I want you to color them. So this would be one color, and these ones would be another color. And what we find is that adjacent angles, when parallel lines, Okay, so not like in this situation that's pictured here. When we have parallel lines, adjacent angles and consecutive angles will add to equal 180. Okay, so you can add those two angles together in that angle pair and they will equal 180 degrees. Okay, what we find with alternate interior angles, alternate exterior angles, and corresponding angles is that they equal each other. They are set equal in those situations. Okay, so if I have angle 1 and angle 8, those are alternate exterior angles. If we had parallel lines, I could say that angle 1 is equal to angle 8. If I had consecutive interior angles like 3 and 5, those are consecutive interior angles. So if they were parallel, I would have angle 3 plus angle 5 equals 180 degrees. We are going to do a proof now to show kind of what that proof process looks like. So if I take my, why are you not working? Turn on the pen. An example. Okay, I have some parallel lines here with a transversal. And if I say that this is angle 70 and angle is equal to 140 degrees, sorry, not 70, this angle is 7x degrees, and the other angle is 140 degrees, then what I'm going to do is I'm going to solve to find all angles. Find all angles. So my first step is going to be to identify my other angles. So I'm going to give some letters, A, B, C, D, E, F, G, H. Okay, by giving letters, then I have something to label them by. My proof is always going to have my claim and my reason. And my reason is going back to all the rules we have used so far. So my first step is that I look and I see that 7x, or angle D, and angle E are alternate interior angles, which means that they can be set equal to each other. So I can say 7x is equal to 140 degrees because they are alternate interior angles. That's my reason. Then I can find what x is. So x is equal to 20. That was by division. I divided both sides by 7. I also know, because I set this equal, that now D is equal to 140 degrees. Okay? Okay, so that solves that first part. Now I want to find another angle. So say I want to find angle B. To find angle B, I know that angle D and angle B are adjacent angles, which means they're going to add to 180. So I can write that expression because they are adjacent angles. Okay, so I see what kind of angle are they? What type? What type of angle are they? And then what property applies? And then you solve to find the value. Okay, so now that I have that, I know that 140 plus angle B equals 180 because I substituted. So then I can subtract 140 on both sides and get angle B is equal to 40 degrees by subtraction. So now I know that angle B is 40 degrees. Then I can do that same process for some other angles. Well, if I know angle B and angle F are, if I look at angle B and angle F, those are corresponding angles, so they are equal to each other. So I'm going to set them equal because they are corresponding. So I looked at two angles, I said, what property do they have? I set them equal. Angle B is equal to 40 degrees, so angle F is equal to 40 degrees by substituting in that value. Okay? And I continue with this process until I have found all of my angle values.